In this video, I want to look at thinking about percent problems and how we can organize our thinking about these basic percent problems. It's important to remember that a percent expresses a fraction as an equivalent fraction that has a denominator of 100. So this means a basic percent problem involves a statement that there are two equivalent ways to express a fraction. We can think of it as p% is equal to a portion over the whole amount. Or in other words, p over 100 is equal to portion over whole amount. Another way to think about this, p% of the whole amount is the portion. Or, worded slightly differently, the portion is p% of the whole amount. One helpful way to organize the information in a basic percent problem is with a percent table. These are going to be of the form p% is the proportion 100% to the whole amount. And by reasoning about percent tables, we can develop a better feel for percentages while solving a huge variety of different problems. Percent tables can allow us to reason flexibly with percentages, while they also allow for a general method, which we call going through 1%. So let's look at an example of this. I want to use a percent table to calculate 6% of $40. Using our percent table, we know that 100% corresponds to $40. So then 1% will correspond to $40 divided by 100, or 40 cents. So that tells me that 6% would be 6 of those. 6 times 0.4. Or $2.40. So we were able to reason through with this going through 1% method. Let's look at another one. A store gave $15,000 to schools in the community. This $15,000 represents 3% of the store's annual profit. What was the store's annual profit? In our previous example, we wanted to calculate the percentage of the total. Here, we have our whole unknown percent problem. We don't know what the whole amount is. We know the percent and we know the portion, but not the whole. So what we do know is that 3% corresponds to 15,000. In this case, 1% would be 15,000 divided by 3, or 5,000. So then 100% would be 1% times 100, or $500,000. For our next one, 3 is what percent of 8? In this problem, we know the whole and the portion, and it's our percent that we don't know. And in this case, instead of going through 1%, it's going to be easier to solve this problem by going through the amount 1. So we know that 1% corresponds to 8. If I divide that by 4, I would get 25%. Well, that's 2. Divide that by 2 to get 12.5%. That would correspond to 1, since 2 divided by 2 is 1. And then to get 3, I would need to multiply by 3. So 3 times 12.5%, which is 37.5%. So instead of going through 1%, since we're missing the percentage, it might be easier to actually go through 1. Another way to reason through percent problems is through the standard techniques of algebra. This technique uses the definition that p over 100 is equal to the portion over the whole amount, and then we would cross multiply. When we do, we get that p times the whole amount is equal to 100 times the portion, and then we can solve this resulting equation. For this, let's calculate 6% of $40, just like we did with our tables. Well, our percent is 6. We know our total is 40, but we're missing the portion. So this is a portion unknown problem. So we would have 6 times 40 is equal to 100 times x. 6 times 40 is 240. And then I can divide both sides by 100. And when I do, I get 2.4 is equal to x. This was in terms of dollars, so $2.40. A store gave $15,000 to schools in the community, and this $15,000 represents 3% of the store's annual profit. So our percentage is 3. This is a portion, so this is the $15,000 portion, and we're missing the whole amount. So we would have 3 times x is equal to 15,000 times 100. Or 3x is equal to 1,500,000. We can then divide both sides by 3 to get our desired 500,000 would be the total. Finally, 3 is what percent of 8? In this case, I don't know my percentage. I know 3 is the portion and 8 is the whole. So we have 8 times x is equal to 3 times 100. That tells me 8x is equal to 300. Divide both sides by 8. And I get x is equal to 37.5, so 37.5%. The next method is to set up equivalent fractions without cross multiplying. So I'm going to set up p over 100 is equal to the portion over the whole. And then I'm going to try to figure out my missing value by just comparing equivalent fractions. So let's look at some examples of this. How much is a 6% tax on a purchase of $50? Well, we know our percentage is 6, and we know our total is 50. Well, to get from 100 to 50, we had to divide by 2. So to get from 6 to here, we need to divide by 2. So the amount of tax would be 6 divided by 2, or $3. As another example, in a class of 25 students, 3 are absent. So what percent is absent? Well, I know 3 out of a total of 25 are absent. For percents, I need 100 on the bottom. So to get from 25 to 100, I need to multiply by 4. So here, I would also need to multiply by 4. 3 times 4 is 12, so the answer is 12%.